Hello, everyone. Welcome back to Tantra's Mantra, where we go behind and beyond the tech news headlines. I am your host, Prakash Sangam, founder and principal of Tantra Analyst. The tech world is still going gaga over AI. There is something new almost every day. Now, I've done many episodes on AI as well on our podcast. Actually, the news cycle or the hype cycle, as some might call it, started with ChatGPT going public, which was Gen AI, Generative AI. Then we started hearing about Action AI or Agentic AI. Then recently, Physical AI, which is for robots. So then the question is, what is the next buzzword that we are going to hear? Well, we are starting to hear about AGI, which stands for Artificial General Intelligence. Although we are hearing about that a little bit more, it's been around for some time. Then the question is, what is it? How is it different from the many AIs we have now? When is it going to be available? And so on. Lots of questions, I'm sure, on the topic. To talk all about those, we have a special guest with us today, and he's no regular AI expert, but the person who came up with this very term, AGI, and that is Peter Voss, currently the founder, CEO, and chief scientist at Aigo. Peter, welcome to the show.
Well, thanks for having me.
All right. So, as I mentioned, I mean, although people are hearing about AGI a little bit more now, it's been around for some time, right? And you've been working on it for a long time. So, in your illustrious career of what, more than 20, 30 years, could you explain a little bit about your background and so on? I'm sure you can go on for a very long time, but just for in terms of AGI, how you started and so on.
Yes, sure. I'll try and keep it short. So, I started out as an electronics engineer and started my own electronics company.
Hmm.
Then I fell in love with software, and my company turned into a software company and actually developing an ERP software system.
Hmm.
And that company was quite successful. We went from the garage to 400 people and did an IPO.
Uh-huh.
So that was really exciting. But it's when I exited the company, it gave me the freedom to think about how can we actually build software that can think and learn and reason and adapt the way human intelligence allows us to.
Hmm.
So I embarked on a 5-year journey of deeply studying what intelligence entails, what makes human intelligence special.
Hmm.
How do children learn? What do IQ tests measure? How does our intelligence differ from animal intelligence? What had been done in the field of AI, and many questions like that. What is consciousness? What is free will? How do we know anything?
Hmm.
So I studied all of these different aspects and then came up with a design for a thinking machine.
Uh-huh.
Then, coming to the term AGI around 2001, 2002, I
Hmm.
got together with a few other people who also came to the point where they said, the time is ripe now for us to start building thinking machines, which
Hmm.
was the original dream of AI from 70 years ago.
Hmm.
Three of us actually then coined the term artificial general intelligence to distinguish ourselves, our efforts from what everybody else was doing, which was really narrow AI,
Hmm.
building machines that can play chess and become world chess champion even, or container optimization, or medical diagnosis, or some narrow field.
Hmm.
Whereas artificial general intelligence
Hmm.
is all about systems that can learn by themselves,
Hmm.
really anything that a smart human can learn.
Okay. Yeah, so the way differentiating it from Chenia and the other things that we are hearing now a little bit more than before is basically, throw in a bunch of data, let them identify trends and apply that training, if you will, to do something very similar to what they have been trained on, right? Whereas the AGI it is learning like a human brain does, right? Not just crunching a lot of data, but actual learning and like a human does. Yes, am I saying that right? Or
Yeah, absolutely. That is sort of the crucial difference between, what Gen AI is doing and what AGI needs to do.
mm-hmm.
In Gen AI, you collect all of the data up front, now 30 trillion pieces of information, you number crunch them, hundreds of millions of dollars worth,
Yeah.
and then you have a model, but that model is read only, it's fixed.
Hmm.
It's cast in stone. The model itself cannot learn new things.
Yeah.
Now, you can have external databases and things, but the model itself cannot change.
Hmm.
That's why they have to throw them away and train a new one. I mean,
Yeah.
if they could update the model, they clearly wouldn't be spending all the money to train new models.
Mm.
So that's one of the serious limitations. You wouldn't a human wouldn't human assistant, for example, or worker wouldn't be that useful if they couldn't learn on the job by themselves. So large language models need to be trained with massive amounts of training data, and they always need a human in the loop to kind of correct them, to tune the system, to prompt engineer it, to build the external databases and so on. So they really cannot learn autonomously by themselves on an ongoing basis. So that's the big difference between what AGI promises versus what we currently have in large language models.
Yeah, I mean, you can still do a little bit of optimization, fine tuning of the models, and so on. But I mean, it is kind of fixed to what function it is trained on and what data is trained on, right? That's what you're saying. You can,
Exactly,
yeah.
exactly. It's limited to what has been fine tuned to do, and also importantly, even that fine tuning requires a human. It requires human intelligence to say, well, what do I need to tune it to? What data do I need to get? What data structure? What prompts?
Hmm.
So it doesn't learn autonomously the way a human would. I mean, a smart human, you can put them into a new job as an intern for software, for customer support, for accounting, for anything,
Hmm.
and they can learn on the job. They know what they don't know. They know when to ask questions, and they can learn incrementally as they go along, and and basically become better and better. And inherently, large language models can't do that. There's also kind of another succinct way to look at the difference.
Hmm.
Our human brains require 20 watts of power,
Hmm.
and a child can learn with something like 1 or 2 million words,
Yeah.
whereas large language models need gigawatts of power. They're recommissioning nuclear power stations to train them,
Yeah.
and they need trillions of training words. So it's literally the way humans learn is with a million times less data,
Yeah.
and that's just a profound difference.
Yeah. I mean, brain is the most power efficient processor out there, right? So, I mean, in terms of Gen AI, we know there are transformer models and so on. How does AGI really work?
Yeah, so that is a kind of a big question right
Uh-huh.
now. You have more and more people. There was a recent survey done by AI researchers, and I believe it was 84% of them said that large language models will not get us to AGI.
Mm-hmm.
So there's already a consensus of large language models are not the path to AGI. In fact, Jan LeCun, the chief scientist of Meta or Facebook,
Mm-hmm.
puts it very succinctly, very strongly. He says large language models are an off ramp to AGI, a distraction, a dead end. So he puts it very forcefully, and he
Mm-hmm.
actually tells the students not to bother learning generative AI because that's not the future. So
Mm-hmm.
there's, I think, a general consensus coming across, um, that large language models are not the future.
Okay.
But the question is, what is the future is much less clear.
Mm-hmm.
Now, our company and myself, we have a clear answer to that, but it's not something that's generally accepted.
Mm-hmm.
And it's what DARPA calls the third wave of AI,
Mm-hmm.
or cognitive AI.
Okay.
So it starts from first principles, saying what is important in human intelligence? What makes human intelligence so powerful? That's your starting point.
Mm-hmm.
Not how much data do we have and how much compute do we have. The starting point is understanding intelligence and then building a system that has the characteristics required for human like intelligence, which means to be able to learn autonomously.
Mm-hmm.
So, so that's the third wave of AI, or cognitive AI.
Mm-hmm.
And the way we are implementing that in particular is with what we call INSA, an integrated neurosymbolic architecture.
Mm-hmm.
So we basically combine the best features of neural networks
Hmm.
and the best features of symbolic logic reasoning in one integrated system. And that is the approach we are taking.
And what is a simpler and easier way to explain it with an example, maybe?
Well, it does get fairly technical,
Yeah.
but large language models, as we know, you take all of the data you have up front,
Uh huh.
the 30 trillion pieces of information, you number crunch them for weeks or months on end,
Yeah.
and then you have a neural network that is represents the sort of statistical correlations between all of the data that you have.
Correct.
Now, with the cognitive AI, with our approach, we have a vector graph database. So we have a database that encodes all of the relationships between different concepts, different ideas, different words
Hmm.
that you learn. But it does it incrementally. So every new sentence you come across, every new action that you come across is now encoded in this graph database.
Hmm.
But there's some unique technical challenges as to make this graph database efficient enough and optimize it in a way that you need it. For example, our graph database is literally 1,000 times faster than any commercially available graph database. So we have optimized it to do that. So you have this knowledge graph that encodes all of the knowledge and skills. And that is basically the backbone of the system. And it can accumulate new knowledge, create new generalizations, have new insights, and that is really what our AGI approach is.
Okay, so let me take an example of, say, image classification, right? So is it possible to differentiate between these two approaches, like how Gen AI does? If I train a model with, say, millions of dog pictures, right? So
Right.
I present another, a little bit similar but a little bit different dog picture as well. Then Gen AI basically looks at all this training, compares, maybe trend matching and so on, decides with certain confidential level that this
Yeah.
is a dog versus a cat. How does that work in AGI?
Right. It's a good question.
Mhm.
So again, going back to first principles of a child,
Mhm.
you can show a child a picture of a giraffe
Yeah,
if it's never seen a giraffe before.
yeah,
You can show it one picture of a giraffe,
yeah,
and it'll be able to recognize a giraffe, a toy giraffe from the back, from the front. The small one, a big one.
yeah,
It doesn't need hundreds or thousands of pictures of giraffes
yeah,
to be able to classify them.
yeah,
And that is basically the way our system works as well. It can learn the features of a giraffe that make it different from other animals and things that you've seen,
uh-huh,
and do that in a cognitive way so that it really only needs to have one picture of a giraffe to learn. And that's kind of really the big difference versus a statistical where you need lots of examples and have sort of the statistical correlation versus a cognitive where you're recognizing different features of the system and you can compare them to other things you already know. And it can learn that instantaneously, like a child. If
yeah.
you show it a picture of a giraffe and it now learns it, it will be able to recognize a giraffe. So it really is very, very different.
Yeah, so I mean, I'm trying to make it as simple as possible without losing the technical authenticity of it. So, would be right to say that in Gen AI, it is more of a statistical trend matching of so many different aspects between what I've learned and what I've been presented match. So this must be it. Whereas in AGI, what you're capturing is not the trends and such, but a character of what is defining a giraffe. So it is much less data than just
Correct.
trend matching, and then you're comparing that to what is being presented. Is that?
Correct. It's in Gen AI. I mean, depending on how the system is trained and that, but ultimately it's the sort of the pixels that you're comparing,
Yeah,
rather than coherent features and how they join together.
yeah.
So there's a big difference. But let me talk about kind of a practical difference and just how important
Hmm.
or how beneficial AGI is and how much more powerful it is than large language models.
Hmm.
Once you have a single AGI that is, say, has all the knowledge, that has had all the training to, say, a high school graduate or maybe a college graduate, a smart college graduate, let's say,
Mm-hmm.
with general knowledge.
Mm-hmm.
You can now take that AGI and literally put it into a call center, put it on a computer in a call center, and it can learn like a human by itself.
Yeah.
It can read the manuals, it can ask questions, can listen to some customer calls, and it can, like a human, like, if you or I were put in a call center, we would learn to do the job by asking questions, reading things, and then actually taking calls. And we would know when we can't handle something, we would ask a supervisor to come over or somebody more experienced. We would ask questions.
Mm-hmm.
And that's it. That same AGI you could put into an accounting firm.
Mm-hmm.
And same again, it could, study the material, do tests, learn, and, then start helping people and become an accountant or a programmer or any of those without a human having to assemble massive amounts of data, fine-tuning prompts, building rags, and all of the engineering that has to be done. And as the job changes, let's say again in the call center job, let's say there are new business rules, or there's a new product,
Mm-hmm.
or there's a snowstorm somewhere,
Mm-hmm.
something changes.
Mm-hmm.
The system can adapt on the fly. You don't now have to again fine tune it, or collect new data and do it. So it really is profoundly different in what ultimately AGI will be able to do.
Okay. You still have to train it, right? But not as a massive amount of data that you do with LLMs, right? And how do you train it? Is training different, I'm assuming, than
Yeah.
LLM?
Well, the thing is, you really only have to train it once
Okay.
to have that general knowledge, to be that college graduate, that general knowledge college graduate, maybe with this different STEM subjects that know some mathematics, some science, and language and so on.
Yeah.
But you really only have to train an AGI once. From there on, it can learn by itself. It can learn autonomously, and that's basically the big difference. Now, how do we get to that college graduate level?
Yeah.
Well, that's what our company is working on right now. Is we teach it like a child from the ground up. We teach it language and reasoning like a 3-year-old, 4-year-old, 5-year-old,
Mm-hmm.
that it can have ever increasing levels of sophistication in its language understanding and reasoning ability.
Mm-hmm.
And of course, as it grows up, sort of as it goes up that ladder, it'll be able to learn more and more by itself. A 3-year-old can't learn that much by itself,
Yeah.
whereas a 10-year-old can already, read books and so on. By the time you're 14 or 16, and certainly 18, you can just hit the books and study things and learn largely by yourself.
Yeah.
So we just have to train up the system to become competent enough to be able to learn by itself.
Yeah. So
And,
it's
that will, yeah,
basically you're training the model how to learn, not teaching it, right?
that's a very good way of putting it.
Okay. Got it. So the issue with human brain is it takes a lot of time, not a lot of energy and data, but it is slow process. So with your algorithms and processes, you are speeding that up, I'm assuming.
Oh yes, it's much faster than a human.
Yeah.
I mean, first of all, as a human, there's only a limited number of hours a day that you can learn,
Yeah.
and humans get distracted by all sorts of things, and especially in puberty, and
Yeah.
some of us are in puberty for 50 years. So, so you have all these distractions, and you basically you can't learn in a very concentrated way.
Yeah.
Whereas with AGI, it can learn 24/7. It can learn at a higher speed,
Yeah.
and also the curriculum we're giving it is optimized for an AGI to learn very efficiently.
Yeah.
So instead of taking 15 years to get up, or 20 years or whatever to get up to college graduate level,
Hmm.
we're looking at a few years maximum. And then as we figure out exactly how to do that efficiently, you'd be able to train something from scratch in probably a few weeks.
Yeah.
It's
So
really then just a matter of how fast the processor is and how effective your algorithm is. But you don't need to keep training them. Basically, you only need to get it done once, because the system can, anything that it didn't learn correctly early on,
mhm.
it'll be able to correct the same way as a human can. If we were taught something or we picked up some wrong knowledge early on in life, later on we studied something and thought, oh, okay, that's actually not the way the world works, and okay, and you basically update your model, so to speak.
Okay. So you basically, once you have that learning, you kind of copy it over, and maybe the newer version of it can learn something different. But so you kind of build a basic learning model, and then let it grow on different expertise.
Specialize.
Okay.
Exactly.
Okay.
That's right.
I
And
see.
you can do that at different levels. So a very powerful example here is
Mhm.
that if you have one AGI that now gets from this, a college graduate level and trains itself, say, to be a PhD level cancer researcher.
Mhm.
Now, once you have that one AGI that has this competence, you can now make 1 million copies of it,
Correct.
and you have 1 million PhD level cancer researchers, which can then specialize and pursue different avenues, and pool their knowledge, and without egos getting in the way, they can share knowledge and transfer knowledge much more effectively. So the acceleration we'll have in scientific research, for example, will be phenomenal.
Yeah. Interesting. Interesting. So, I mean, this is, as you mentioned, this is going on for some time. Why is it critical now? Why are we hearing more about it now? Is it because of the AI hype, or is the technology at a tipping point where a lot of things that were just concepts are able to be implemented in physical form now?
Yeah, it's a good question. We coined the term AGI in 2002,
Yeah.
and I believe we could have made good progress towards AGI even 20 years ago,
Uh huh.
but there just wasn't the funding. It was just, people thought it was too way out and too far out in the future.
Uh huh.
So it was difficult for any of the projects working on AGI to actually get enough momentum and funding to make progress.
Yeah.
Now, with 2 years ago when ChatGPT hit the scene, suddenly everybody became very, very excited, and for good reason, because it's really quite phenomenal what these large language models can do.
Yeah.
So now there are massive amounts of money being thrown at it. I mean, recently the startup that had $2 billion seed seed round.
Yeah.
I mean,
Yeah.
no product, no, no revenue, and no particular roadmap,
I,
and
I,
you
I
know,
think you're talking about the one started by CTO of
yes.
OpenAI, Mira
Yeah,
Murati, right?
right.
Yeah.
So,
Yeah.
there's obviously a lot of excitement, and large language models, ChatGPT, in a way show us we seem to be so close to AGI. You can almost taste it, the way they interact, the way they can summarize and do magical things.
Yeah.
It's really very, very impressive. So on the one hand, we seem to be so close to AGI. On the other hand, we seem to be so far from it because they cannot learn by themselves. They hallucinate, and all the problems that they do have. So I think now there is kind of a much better understanding of the value of AGI,
Mm-hmm.
that it is a multi-trillion dollar opportunity,
Mm-hmm.
and how it can help humanity in so many different ways. So there is much, much more excitement about it. What is lacking at the moment is really a clear vision of what will get us to AGI. Now, we have that clear vision, but, we're a small company, and
Mm-hmm.
that hasn't it hasn't really, there isn't consensus on what is the right path to get to AGI. But definitely the time is ripe now, with the excitement generated by large language models.
Yeah. And you think it's possible to see this in action in with commercial use cases and so on in next like couple of years, 5 years?
Oh, absolutely. I don't believe there's any significant barrier from a hardware point of view. I think the hardware,
Mm-hmm.
we either already have enough hardware power, or we soon will, in the next 2 years. It's really a matter of doing the additional software engineering
Mm-hmm.
to build a system that can really learn as flexibly as it needs to, and form concepts on the go, and what we are basically working on. But absolutely, I believe that within a few years, 2 3 years, we could have full adult level AGI if the right resources are are directed at the right kind of projects, the right kind of approaches.
I see. And in terms of hardware, today's mix of CPU, GPU, NPU, DSPs, are they enough,
Yeah,
or
I
do you
think
need different kind of hardware for this
so.
processors?
We currently doing all of our work on standard off-the-shelf computers, not even very, just ordinary desktop computers.
Okay.
We're not even using GPUs right now.
Okay.
We'll probably, as we scale up, we'll start using GPUs, but nothing very fancy. So they'll be able to run on a standard off-the-shelf computer. Now there will be possibilities to optimize it by having FPGAs or some custom hardware
Mm-hmm.
that will. You can always do it. I mean, you can always get like 100x or 1000x or even 10,000x improvement
Yeah.
by designing hardware that is optimized for some particular software algorithm. So there will be possibilities for optimization, but I don't see that as essential to actually get to full adult level AGI with basically off the shelf hardware.
Okay. And where are you with Aigo? What stage are you in
So
technical development?
Yeah, and so until about 8 months ago,
Uh-huh.
we still had a commercial operation. So we had our proto AGI technology
Uh-huh.
that we deployed in the call center. Very effectively. Last year on Valentine's Day, our customer 1-800 Flowers, we replaced 3,000 agents that they normally had to hire for 2 weeks. They have this massive rush of a Valentine's Day period.
Yeah.
And using our technology, we replaced 3,000 agents very successfully.
Uh-huh.
Now, we decided 8 months ago to put our commercial business on hold because it was really too distracting, where we really needed our company to focus on increasing the learning ability of our system. So that's what we've been doing. But, we're a small team. We're only 15 people in total.
Mm-hmm.
So right now we are looking for Series A to basically scale our team up and accelerate the development so that we can get to full adult level, learning and reasoning ability, we believe within 2 years.
Okay. And I'm assuming, I know, as you mentioned as well, all the big AI players, be it Google, OpenAI, Amazon, Meta, they are also looking at this as well, right? So, how do you carve out your own space when you are
Well,
not directly competing, but in the same space as these
yeah.
behemoths?
Well, actually, they're not at all looking at the same thing because they all seem to be stuck. The expertise they have
Uh-huh.
is always with big data, big compute.
Okay.
Their way of thinking about the problem is we need more compute, we need more data, we need scaling, and somehow magically will overcome the limitations. I mean, there are the rare public voices like Jan LeCun who says
Mhm.
he's done with Gen AI,
Yeah.
but really pretty much all the players in the large language model space are still pursuing the sort of big data pre-training approach.
Uh-huh.
And it's, that's what they know. That's a hammer they've got. So to them, everything looks like a nail.
Yeah.
And I think the transition from second wave large language models AI to third wave AI, cognitive AI,
Uh-huh.
is much more likely to happen through new companies
Uh-huh.
that don't have that history of their big data thinking. So they're really not competitors in this race.
Yeah.
It's just such a different mindset, whether you're trying to brute force the problem
Mm-hmm.
or whether your starting point is understanding intelligence and focusing on building the key requirements of human intelligence.
Mm-hmm.
The absurdity is, because we don't need massive amounts of data, massive amounts of compute,
Yeah.
the amount of money we need to get to AGI is also a tiny fraction. It's like a rounding error. I mean, we're looking at $25 million to, hire another 50 people for 2 years.
Yeah.
Talking 25 million as opposed to billions and billions of, or hundreds of billions of dollars.
Yeah.
It's a completely different mindset,
Uh-huh.
and it'll be interesting to see how over the coming months and years, those large companies will basically come to the conclusion that they have a dead end, like Jan LeCun says. You know,
Yeah. And you said, a third phase of AI. So how are you defining is first phase regular machine learning, and then second was Gen AI, and third is cognitive AI. Is that how you're?
And no, actually, it's something that DARPA came up with a few years ago. They
Uh-huh.
call it the three waves of AI.
Okay.
And the first wave of AI is actually what people now call good old-fashioned AI.
Okay.
So that is basically, logic-based, primarily logic-based systems.
Okay.
So IBM's Deep Blue World Chess Champion would be a good example.
Yeah.
Expert systems would be an example. That's the first wave.
Yeah.
And the second wave is really deep learning, machine learning, Gen AI, all the big data statistical approaches.
Okay.
Basically, when people figured out how they could get neural networks to do very impressive things.
Yeah, okay, got it. So there's so much of investment already going into Gen AI. Don't you think that kind of becomes a impediment to what you're trying to do in terms of, without requiring this huge amount of data and investment to get to this AI? Do you worry that because there is already so much of investment by these big companies, they'll brute force from Gen AI somehow a linkage or a shortcut to AGI? You think that's impossible?
Yeah, I believe it's impossible. And there are
Okay.
good theoretical reasons for that.
Hmm.
So, I mean, first of all, just the word GPT.
Yeah.
G is generative, it makes up stuff.
Yeah.
And that's why you have hallucinations,
Yeah.
and that's inherent. In fact, there's quite a couple of papers coming out now saying hallucinations are getting worse, not better, as
Hmm.
they scale these things up. So hallucinations will be there, but more importantly, GPT, the P, is pre-trained.
Yeah.
And that's the Achilles heel.
Yeah.
You cannot have proper high level human intelligence with something that cannot learn and adapt autonomously in real time, incrementally. And the transformer technology and similar, any variations of that, reinforcement learning or any of these big data learning approaches, lock you into this bulk training.
Yeah.
They lock you into the requirement that you need to have all of your training data up front
Yeah.
and number crunch it. You can't get away from that. So, and that's again why I agree with Jan LeCun. He says that he's done with large language models because they are dead end. They cannot be tweaked. So no, now there's still a lot of money to be raised, a lot of money to be made, a lot of hype. You have all these consultants making a lot of money trying to get large language models implemented in different companies,
Hmm.
and not with very great success. But there's this whole hype machine. There's so many people interested in making money out of this and making largely false promises in terms of how it can do all this magical automation in companies. But as we're getting reports back from enterprise companies saying this isn't really working very well, it's not reliable enough, needs a human in the loop, we can't have this customer facing, and it's costing a fortune to engineer. So
Yeah.
this bubble is going to burst, undoubtedly. It's been oversold, but there's still, it still has a lot of momentum to go.
Yeah, I mean, it's so much of investment has gone in. I mean, there are some return on investment that they're seeing, but it is still a money pit, Chania, as such, in terms of investment. So it's more of a funds inward thing, and we still have to see what the return is going to be on it. So yeah, we'll see that. So and going back to this, yeah, AGI training like a human, how do you manage and control that learning? You have enough knobs, in terms of where it should stop learning, or what
Mhm.
it should learn, what should not learn, and so on. Humans are complex, and the ingenuity of human brain is because it has no controls as such, right? So how do you manage this dichotomy? You only want to make it learn as much as you want to, but not more, not less.
No, that's not really the case. I mean, the
Uh-huh.
system inherently needs to know, like you train a human,
Yeah.
of what is appropriate to say and do in a given context.
Mm-hmm.
What is appropriate to tell a child, what is appropriate to tell an expert in a particular system.
Yeah.
But the whole training question is quite interesting
Mm-hmm.
because half of the people in our company are what we call AI psychologists.
Mm-hmm.
It's actually a profession I invented, but their job is to come up with the curriculum for our system.
Uh-huh.
So they have a curriculum of teaching the system and then testing it. So we also write the tests or use existing tests for
Uh-huh.
children. So we're training and testing the system on an ongoing basis.
Yeah.
And as it develops, we obviously will also make sure that it has the right kind of balance of being helpful to the user, but also knowing what is appropriate. So that's part of the kind of curriculum of giving it that ability to have the right conversation. And that's really the reference point is always how humans learn. And
Mm-hmm.
how humans, we learn context, we learn what is appropriate in different circumstances.
Mm-hmm.
And there are a lot of similarities in teaching an AGI and teaching a human.
Yeah, I mean, but there are also bad humans, right? Criminals and so on. So, how my question is more on, this doomsday scenario of AI controlling humans and vice versa. If the machines will start learning like humans, develop expertise
Yeah,
like humans, develop
right.
like and be started behaving like humans, then how the outcome can be different than how the humanity is now, right?
Yeah, it's a very interesting and a big question. I mean, first of all,
Yeah,
really civilization has been getting better and better
yeah,
as people become more rational.
yeah,
I mean, I think we'd all rather live now than 100 years ago or 1,000 years ago or 10,000 years ago.
yeah.
So, that's kind of one point. So I think it's pointing at humans as they become more knowledgeable, more competent, more rational, they actually also become more moral,
Hmm.
better. But there are other dimensions to that. Unfortunately, Hollywood has sort of pre-programmed us that AIs are the bad guys and AI will kill us. I mean, that's kind of what makes for a good story.
Yeah.
But it's not actually the reality because there is a very big difference when I say the teaching is similar to a human,
Hmm.
but that is only as far as cognition is concerned, as far as language and reasoning is concerned.
Okay.
As far as emotions are concerned, AIs are completely different.
Hmm.
You know, humans, as humans, we are driven basically by our
Emotions.
genes
Yeah.
for survival and reproduction.
Uh-huh.
I mean, that's really the fundamental. Otherwise, we wouldn't be here
Yeah.
having this conversation if we weren't.
Yeah.
So humans inherently are driven by reproduction and survival.
Uh-huh.
But that also causes a lot of the problems, that causes wars and jealousy and anger and, a lot of things like that really are byproduct of these primitive drives that we have.
Hmm.
And an AGI will simply not have them. An AGI doesn't have that biological substrate and that reptile brain. It doesn't have a drive to reproduce or to protect itself even.
Yeah.
So from that point of view, you shouldn't think of it like a human and that it will, want to take over the world or protect its ego or, get jealous or something like that. It's just not going to happen.
So through this learning process, machines will not develop emotions, because I mean, if they want to, like taking your chatbot example, if they want to respond to a question by a customer like a human being, they have to, one, understand the emotion of that customer, whether it's angry, whether
Mhm.
he or she is, what state of mind
Right.
he or she is in. Which one is that they have, the machines have to understand that emotion. For them to understand that emotion, they have to know what emotion is, in which case they may develop those emotions as well, right? Don't you think?
No, actually, it's a very good question. And
Mm-hmm.
the answer is no.
Mm-hmm.
There's a difference between feeling an emotion and being driven by it and
Okay.
recognizing it.
Okay.
You could take, for example, a good psychologist.
Mm-hmm.
A good psychologist can totally understand and empathize with your emotions,
Uh-huh.
can recognize them and know how to respond to them.
Yeah.
An angry customer or somebody depressed or suicidal or whatever it might be.
Uh-huh.
But, a psychologist isn't going to feel those emotions themselves at that time.
Okay. That's
Th-
good.
You
That's a
know,
good point. Yeah.
so having the emotions and affecting them how you motivates you to act in the world is quite different from recognizing the emotions and knowing how to respond to the other person having those emotions.
Yeah, okay. And you're saying as part of that learning, they will not learn developing
how to
emotions of
deal, how
human
to
essence. Yeah.
yes, how to to recognize and how to deal with different human emotions.
Okay. All right. That's a good point. So you're saying, we have seen humanoids nowadays, right? Any show you go to, there is a humanoid, of course, being controlled by a human being. But you will not see these humanoids with AGI becoming cyborgs and becoming Skynets, and you've seen in the Hollywood movies.
Yeah, well, no, again, they simply will not have the motivation. Now, can humans use AGI for bad purposes?
Yeah.
Absolutely.
Yeah.
But as long as you have more good guys than bad guys, and that is typically the case,
Yeah.
the good guys will have AGIs to help us protect us from people who try to use AGI for bad purposes. And there's also another protection in, but this comes to a very subtle philosophical question that I've actually studied and written about,
Mm-hmm.
and that I believe is that having an AGI
Mm-hmm.
will also make people, make people have better decisions. And I can very quickly go over an example here.
Sure.
All your listeners here will have gone through 9/11, or certainly will know about 9/11.
Yeah.
And the human limitations there are very, very clear.
Mm-hmm.
So the first thing is we tend to act emotionally.
Mm-hmm.
After 9/11, we've got to hit back at somebody. We've got to
Yeah.
go to Iraq or Afghanistan or what. We've got to hit back at somebody.
Yeah.
So that's
Take
an
revenge. Yeah.
emotional reaction.
Yeah.
Now, an AGI is not going to act emotionally.
Mm-hmm.
It'll say, okay, this is terrible. Let's think about this. The second thing is humans are not very good at getting objective data.
Mm-hmm.
Weapons of mass destruction, check. We don't have the time, the patience, the skill to really do research and say, well, is that true?
Mm-hmm.
you know and we tend to also suffer from our preconceived ideas and of what we like to hear and so on. Again, an AGI will be much better at doing the analysis and saying, okay, what are the facts? Are there weapons of mass destruction or not? Or what is the whole story? So it's a second thing. We'll have better informed decisions.
Mm-hmm.
And the third one is related to that, and that is we are not very good at logical thinking.
Yeah.
So, even if you say, okay, we should go to Iraq and weapons of mass destructions were there, we should ask ourselves, what is the outcome? If we
Mm-hmm.
achieve our objective, will that actually serve our purpose?
Yeah.
So to think things through, or is there a better way of achieving the objective that we want to achieve? Again, AGI will be much better at thinking through logically the repercussions of a particular action and coming up with better alternatives. So anybody who has an AGI as an assistant, as a helper, as a guide, will actually become a better person because they're much less likely to make the mistakes of emotional action with too little information, or action that haven't been thought through properly. So in a way, anybody who uses AGI, it'll be like they have a little angel on their shoulder.
So you're saying it's basically all the positives of a human brain in terms of logic and intelligence, but without the baggage of emotions. You're saying
Yeah, without the baggage of the sort of negative emotions.
emotions. Yeah.
Yeah, exactly.
All right, that's a great point to close our discussion on it. Thank you very much, Peter. This was a fascinating discussion, and I'm sure we'll discuss about AGI quite a bit as we move forward.
Yes, thank you.
Yeah, thank you again for all of your insight and coming on to Tantra's mantra. As I mentioned, it's a lot to be learned and a lot to see in AGI. I'll be closely looking at it, and maybe we can meet again here on this podcast, few months or next year, when we think AGI has made another major step, right?
Yes, indeed.
So, folks, that's all we have for now. Hope you found this discussion informative and useful. If so, please hit like, subscribe to the podcast on whatever platform you're listening this on. I'll be back soon with another episode, putting light on another interesting tech subject. Bye bye for now.